All right. Hello, everybody. Welcome. So today we're going to be talking to you about how to expose complex business logic to a REST API. So here to my right, this is Peter Templey. He's been a dev on the platform for 5 years. I've been an admin for 7 years, and I'm approaching this from a business perspective to kind of address all the different use cases, and Peter is then going to dive into how we achieve these things. There we go. So why do we need a REST API? So in this example, this is a two-object structure. This is where we are referencing a few custom objects that we refer to as an order. So there's a parent object and a child object. And out of this structure, we want to be able to create or update records from a variety of different interfaces. Maybe you're coming from mobile, maybe you're coming from the web, and sometimes when you interface with all the logic that we created here, you might want to just use it as a calculation service. So maybe you want to calculate a price, or you want to calculate tax. So there's all these different use cases where you need to be coming in to attack all the logic that we've built. But it would be much easier to do this if there was just one central focal point to be able to access all this logic without having to write it custom in every single approach that you want to do. So I'm going to hand this off to Peter to explain how we go about doing this.
Okay, so usually in Salesforce, when we are building our data models, we are starting from a record and manipulating fields or adding some child record. So for example, here we are creating a sales document record, adding a couple of line items, and adding a discount code. This triggers calculations, rolls up, roll downs, and finally we get our final price calculations. So my point here is that in Salesforce, the business logic usually is very tightly coupled to the database. So almost every business operation is triggered by a database manipulation, a field update, a record insertion, record deletion, record update. For example, when we implemented our billing application, we created a lot of triggers, and every trigger is bound to a record. Every trigger has some kind of rule which tells the trigger if it should run or not run in a certain database operation. For example, when we're adding a discount code to a sales document record, it starts a trigger, which trigger filters the inserted records if it has a discount code field update or not. So the point is, again, every business operation is very tightly coupled to the database. This is important because when we want to open our business logic to a REST API, we are not always want to make things on a database. So, for example, we had a use case when we wanted to open our price calculation logic to a third-party web application which used our business logic as a price calculation tool, but we did not want to manipulate our database. The problem with this was that our business logic was triggered by the record operations. So we had here a problem. So this is how the REST API works. Probably most of you knows how a REST API is opened to a web service. We have an endpoint. It has an authorization, and after that, application can talk to a endpoint which is connected to an to a Apex class. So in this example, we are showing very same use case which was shown in the classic layout. Let me go back. So you see here 2 line items, 1 discount code and 1 price calculation, and we see the very same thing here. We are adding line items, some line item properties, and the discount code. When we're sending this data to the endpoint, which you've seen there, it results basically a JSON string as a response, and it makes all the price calculations at once. The problem with this that our price calculation is run by triggers. But when we don't want to save our price calculation to a database, we can't really start a trigger, because if there is no database manipulation, triggers just don't run. So how to solve this problem? The solution to this is that we need to decouple our triggers and our database, our triggers and our business logic. So what we did is we created a so-called service layer. Service layer is basically a collection of classes which can run unique business processes with well-defined use cases. They have some input parameters, and they usually have a very simple output data. Let me show you an example. This is a trigger. So when we're starting a discount code operation in a sales document, we want to apply a discount code logic on the price calculation. However, we are not putting all our data to the trigger classes. We are outsourcing the business logic to a discount service. We are passing some very basic data, just the needed data to the discount code service class, and all the business logic is done by the service class. Let me show you our service class for this particular use case. So it gets some input data, and it runs the discount code application use case. What is important here again, that we outsourced the business logic into other classes. We called them wrapper classes. For example, you can see here a sales document wrapper class and a discount code wrapper class. These are basically business entities which are represented by Apex classes. These wrapper classes has properties which are usually business properties. Like, for example, a sales document can have price properties, billing data properties, line item properties, and so on. Discount code can has properties about when and how to apply this discount code. The model classes also have methods. Methods usually represent business operations. For example, the discount code has a method called apply to sales document. And as you see, apply to sales document getting as an input sales document model class instance. So basically what is happening, discount code instance makes a business operation on a sales document instance. So to wrap it up, what are we doing? We are outsourcing the business logic from database through the triggers to the service layer. And from service layer, we outsourcing all the business logic into business entity classes. Okay, so how it is all works with the REST API. So what are we doing with the REST API? We are basically opening our business entity classes to the REST API. So this is what you see here. This is our endpoint implementation of the price calculation endpoint. What is happening? We are creating a sales document entity class using the incoming data. Basically, we are deserializing the JSON dump, building a class, calculating the price properties, and at the very end, we are doing nothing else, just dumping back everything from this business entity model class to the web service endpoint. What is happening inside the calculate method? Again, this is outsourced into the very business entities. So again, it's very simple. We are building our classes, building line item lists, which are coming from the incoming data, applying a discount code, if there is a discount code. The discount code entity is already built by the API using the incoming data. And these business class entities doing their business. So basically, we don't really need to know what is happening inside. We're just opening our existing business logic to a web service endpoint. So to wrap it up, our problem was that our business logic was very tightly coupled to the triggers. Every business operation was started from a trigger operation, which was triggered by record insert, record update, field update, you name it. The REST API doesn't really like it because the REST API, the REST architecture is working with calls. So you send all your data at once, and you are getting all your result data in once. You cannot add more fields on the fly to a REST call because we don't really work with sessions when we doing the REST protocol. That's because we need to create a business logic which can be run independently from the triggers. That's why I created a service layer and the domain entity layers. And finally, we opened all our business instance class entities to the REST interface. Of course, in reality, this is a little bit more complicated, so we are not opening everything to a web service because it's not needed, and some data is better not to send to a REST API. But basically, this is how it works from a very, very basic perspective. One more thing, when we started to build it, we realized that it's good to think about these levels of architectures at the beginning, but it's also good to not to build everything at once, because if we build a simple application implementing all of these architecture layers, we can end up with a lot of coding with not so much and not so quick results. Thank you for your and if you have some questions, please come.